Thank you, Logan. I appreciate everybody taking time to spend a few hours with us today to participate in the platform engineering workshop. We're going to start with what the platform engineering is and what's the kind of impact that this approach will have on your organization's ability to bring products to market sooner. Um, the agenda for today would look like we completed the lab setup. We're going to discuss a little bit about the benefits of taking a platform engineering approach. We're going to go through how to organize uh, internally. We have obviously every organization like yours has many number of lines of business, many application portfolio teams, and many developers and DevOps engineers participating in delivering value to your business. And then we're going to look at pipeline orchestration, which is more focused on how business functionality that is implemented in a developer's workstation gets packaged and delivered to an environment of your choice with the steps that you want to incorporate in your path to production. And integrated security, you want to make sure minimize the risk of exposure of having your application code and production environment being exploited by bad actors. As you want to have some security guardrails, and we want to see, and we are going to see how those security paradigms can be seamlessly injected into your SDLC process. And any good process, we should have ability to measure and understand the impact that we are having with this current approach. Um, Along the way, if there are better ways of doing it, if we don't see the impact that we want to see by looking at those metrics, we can always fine tune and revisit the various steps that we completed in the prior steps. And we're going to conclude with and give you an opportunity to ask questions in the end. But at the same point of time, we have a Q&A section. So at any point of time, if you have any question, feel free to post your questions there. My colleagues are available to answer them asynchronously. The first step, platform engineering is all about people and creating a developer experience that users want to come join in. Your first task is to identify different ways you can achieve this using GitLab. So in a jest, you want to make it more attractive to your developers and other stakeholders, by providing them the tools and making them available at their fingertips. And we are going to see what approaches we can take. And this slide just gives you an overall landscape of where organizations normally have acquired over a period of time, um, primarily for two reasons, maybe through multiple acquisitions. Various tools are being used by the companies that get acquired, or if your IT organization is siloed a little bit, every individual team would want to accomplish their own goals independently, and that introduces quite a bit number of tools. So either way, this is something that we see in most of our customers' environments. The tools sprawl, what are the challenges of it? Not all of them lead to the best case scenario or desired state when you look at the holistically as to the what kind of outcomes that you want to achieve for your organization. Tool chain, multiple tools, friction and overhead, fragile integrations. All these vendors might not provide integrations for you to stitch together a platform to deliver the outcomes that you want to. And sometimes organizations might have to implement their own integrations. In that case, it becomes really hard to scale, and which might result in outages. And you require the custom support for orchestration and integration. You might have a limited set of team members that have implemented these fragile integrations. So they are stretched to provide that support. And making it hard for organizations to measure their transformation, primarily because you have various metrics residing in these respective tools. It's really difficult to have a holistic view of a measure the success from the idea to delivery in a production environment. And it also makes it hard to collaborate, primarily because of the context switching that various stakeholders have to do between an IDE and various other tools. And this results in increased cost because you're kind of using multiple tools, and also time in terms of amount of time that you have to spend with these respective organizations to get the support you need. We're going to talk about some of the approaches you can take. One of the first one is the golden path approach, key to results and platform engineering. This involves setting standard workflows, reusable tools and services that are key to platform engineering and driving success. Now, additionally, platform engineering thrives when you build the right developer culture. And what I mean by that is your platform team needs to treat the platform as a product, just like you treat any complex business application, a e-commerce application, or anything that you make available to your end customers. You essentially want to inculcate the same culture within your platform team to treat your application developers, DevOps engineers, security folks, and everybody internally as customers. And then you listen to their feedback as to what would make their life easier in terms of achieving their goals. Emphasize delivery on results. Now, as all of us are aware, whether it would be a startup company or a established company that's launching new products or new features for their existing products, it's achieving that product market fit sooner um, determines the success of your organization. And achieving that product market fit sooner means that you have a feedback loop, very tight feedback loop, which minimizes the time between idea to delivery. You iterate continuously, getting feedback on the product that you made available to your customers, and then improvise your product and get closer to the product market fit. So that involves making certain tools and processes solidified that your stakeholders can quickly adapt and shorten that idea to delivery. And measure your success. It's not only about implementing, but you also need to make sure you have visibility into certain metrics that you can measure to identify if there are any bottlenecks or you're achieving the desired results. Um, and focus on majority. What I mean by that is, in order to make this platform um, widely adaptable or widely attractive to internal stakeholders, focus on having majority impact. What I mean by that is, if you have, say, all your new application development or modernization of existing applications, the end target of deployment is a containerized environment such as Kubernetes. You might want to focus on that particular path to production and make reusable components available to your internal teams, whether it would be packaging of applications as container images, or whether it would be integrating with Kubernetes dial tones seamlessly, ensuring those components available. So you simplify that particular golden path to maximize your impact to the organization. So focus on that area. So by doing platform engineering correctly, you will deliver results faster, increase your security and compliance, and have happy stakeholders. Um, this is Magic Quadrant, Gartner's Magic Quadrant, where it shows GitLab as a market leader right on top of everybody else. And a short list of the customers and then the outcomes that they achieved by using GitLab as a platform of choice for their DevSecOps. So planning our work. So we're going to go to the group that we just provisioned. So if your group provisioning is done accurately, you should be in this location, my test group section. And then I would want to, in preparation for executing our issues, I would want to open another, similar tab just like this. So we have two tabs with the group. Then I just want you to organize your screen in this manner. So you have two screens with the same content. On the left-hand screen, I would go to this issue section, and then we are going to start with our planning with work issue. And then I'm going to starting with this, I'm going to assign this issue to myself by clicking on the assign yourself button. Um, the first step is, this issue provides you hands-on instructions for the part one of the workshop. We are going to look at as to how do you organize internally as we have multiple teams working on multiple projects associated with different lines of business assigned ourselves. And this suggested that you keep this issue open in separate tab. So if you have it open in separate tab, now once your project has been imported, this is the particular project that we are going to work on, the Tanuki Racing Platform Engineering Workshop project. You may have a number of questions on how to get started. Now, GitLab's newest AI features, GitLab Duo Chat, can help answer those and more. So start by clicking the GitLab Duo Chat icon on the top right of your screen. This is the location on your right-hand screen where you see the GitLab Duo Chat icon. Now we have that window expanded. I would want to ask my AI companion a simple question. Where can I see my projects, issues? So you see on the project sidebar, click on issues in the left-hand sidebar menu of your projects, and then you can see your issues, and then there's issue boards, milestones, iterations. We're going to look at the issue boards, milestones, iterations later in this workshop. But at this point of time, I just wanted to demonstrate that you have a chatbot that is readily available at your fingertips all throughout the platform. So we are not going to spend a lot of time interacting with chatbot today, but if you're interested in getting your hands on the various capabilities of the Duo chat and then the Duo, the AI tooling that's embedded into the platform and made available at various places, there's a dedicated workshop that you can sign up from the same place you signed up for this workshop. So I would strongly encourage you to do that. Moving on. We are going to look at labels. Labels are something that we get that we can associate it with our issues, so we can bucket them together to make sense out of it. And then labels are also used in terms of tracking work. We're going to see in a later section. So at this point of time, we are going to follow the instructions on left-hand side, manage labels. And we are going to create a few labels here. On the top and right-hand corner, you see a new label. And the first one we're going to create is P1. Let's go ahead and pick a color of your choice. I'm going to create a few other ones. CICD. New label for security. We're going to create a new label for workflow in progress. I'm going to select a light green button, light green color. We are just there, not enough to turn it completely green. I'm going to create the last one. We are very close to delivery. So I'm going to pick a dark green there. Now we have completed the step 2 of creating a few of those labels. And as you can see, I have my labels visible here. We're going to go to next step, use the left-hand navigation button to navigate it to plan and issue boards. We're going to create a custom dashboard for ourselves, issue board. Um, create. Going to drop down here to create a new board. And I'm going to enter the title for that, a theme scoped board. And I'm going to make sure that ensure that the show open list and the close list checkboxes are selected. Let's go ahead and create it. And then I have my team scope board displayed in the drop down selected. So make sure you select that. We're going to create a new list button on the right, set the scope of it. Set the scope of it to the label, and then select the work in progress label that we just created and add it to the board. And then we're going to create a new list and select it to the label again. And we are going to select the work in flow review to the board. So as you can see, to our custom issue board, we have created we created new lists. One is workflow in progress and one is workflow in review. So we had issues in the future. If they contain scope labels, they will automatically appear in the labels board. So it's essentially we created an issue board, and then configured lists, and then we are going to, when we create new issues and then tag them with these respective ones, they are going to be reflective in this list here. In step 4, we are going to create a project milestone. The left-hand side, if you see the project milestone, we're going to go ahead and create a new milestone. I'm just going to copy here from here the platform engineering golden paths. I'm going to select the start date as of today, April the 17th. And then I'm going to select the due date 1 week from today, April the 24th, and create a milestone. Create issues. Let's go ahead and create some issues. Navigate to the plan issues section. And let's create a new issue. So I'm going to click the issue section here and then create a golden path reusable CI/CD called CI/CD component as the title for my new issue. The description area, make sure you're in plain text editing mode. So we are currently in the plain text editing mode. And then we're going to use the AI feature that's available here and the GitLab Duo to actually generate the issue description. I'm going to copy the issue description from here and then ask the AI tool to create a description for creating a reusable CI/CD component to build and do base testing for our company. So you see that the AI tooling kind of generated, some requirements, build process, base testing, integration capabilities, and acceptance criteria. Um, Go ahead and create this issue. We're going to assign it to myself, assign it to the milestone that we just created, assign some of the labels that we just created, the P1 label, and then the CI/CD label. Give it a weight. We're going to give a weight of 2. Select the due date. The start date, we're going to make it today's date, April 17th, and then the end date, we can select it as a week from today. And go ahead and create this issue. We'll go back to our issues section. You see our newly created issue. You can go ahead and create another issue, the second one. We're going to mark the title that issue as integrate a pipeline execution policy. We can execute the same process of using the AI tool, the GitLab Duo AI tool that's available. We're going to ask the AI tool to provide a short description around creating a pipeline execution policy that enforces the running of multiple scanners to be used at scale. I'm going to go ahead and assign it to myself. And I'm going to assign the labels that we created, P1 and security. I'm going to give it a weight of 3. I'm going to select the start date for today, April the 17th, and the end date for a week from now, April the 25th, 24th. And then go ahead and create this issue. Now we have a couple of issues created. Let's go back and see how these issues get reflected in the issue board. Now we have these 2 issues, the golden path, create reusable CI/CD component, and the golden path, integrate pipeline execution policy that show up in the open section. I have to I'm trying to look for the board that I created. I can't find it. So you can see the theme scope, the issue board is at the group level. So I have these two issues that I just created are visible in the open section. If I go ahead and drag them into the workflow in progress sections, and then you open the golden path, create a reusable component, you would see that the label changed to what we assigned it to the issue board itself. And then these things change as and when you move these on the issue boards. You have the new label that is work in full progress. So it's essentially visually maintaining the status of the issues that your application developers are working on at any point of time. We're going to go ahead and look at some of the project milestone charts that we created. One project milestone that we created, platform engineering golden paths, and then you can see this shows you the burn down chart and the burn up chart, essentially um, the how efficiently these issues are being worked upon, um, and then the, the amount of hours that your application developers are spending on those. So we completed the first section of the workshop. We can go ahead and close it. Um, so I'm going to go through slides. This is the section that I should have gone through first before we did the lab, but I'm going to go ahead and complete this. Now that we have a plan in place and we want to be able to track our work, this will act as a base for the rest of our development without having to leave the GitLab platform. So organizing work, so we talked about the top level approach is going to be at the highest level would be your organization. And then you would want to organize internally in some fashion. Groups allows you to organize based upon your lines of business or a um, significant product group. So you can have multiple groups as well. Or if you want to use subgroups to organize further within your lines of business. Um, such as if you have a large e-commerce system, you might be a group that is responsible primarily for order management, one group that is primarily responsible for category management, one group responsible for payment processing, order management, delivery, shipping, and all of that sorts. So you can organize subgroups, and within that, respective projects, individual projects where actually the source code resides, and then you can have access controls defined at the group level, subgroup level, so that appropriate people get access to the projects underneath those constructs. Now that we have decided as to how do we organize ourselves based upon organization, groups, subgroups, now it's time to define some work. Now epics provide grouping of epics, or I would say sub-epics and issues. Now epics can be the strategic initiatives across the organization, idea creation for the line of business or major product enhancements, like version 2 of your e-commerce platform, or if you're an insurance company, a new policy administration system, any of that sort. And sub epics represent smaller pieces of the larger epic, as we discussed. Multiple. If you have, break it down into more manageable um, constructs of your teams or the work that you want to define. Sub epics is a place to do. Issues describe more small, discrete pieces of work, something that you can assign to an application developer to work on something meaningful work that can be independently delivered. And tasks help as to what individual task that needs to be completed in order to accomplish a particular technical requirement or steps necessary to complete it. Issues can be stories for building new products or services, enhancing existing capabilities, or if a defect is identified in a production system, an issue can be, defined and assigned to an application developer to work upon it. And then tracking work. Roadmaps display epics within a group on an existing timeline. They exist at group and subgroup level. So it's at a much broader scope compared to the other two constructs that we're going to talk about. Iterations track issues over smaller periods of time, like a sprint or so. Milestones group and track issues and merge requests against a set period of time at the group, subgroup, and project level. So this picture gives you kind of a holistic view of how do we plan, as to how to organize ourselves, how do we define our work, and how do we track the progress of the work that is being accomplished by our developers and other stakeholders. On the left-hand side, organization, if you see, it's a more of a vertical view as to how do we organize ourselves. Group is a bucket of subgroups, subgroup is a bucket of projects. The one in the middle, the definition of work, you can also look at from a vertical perspective. All issues are part of a project that roll up into subgroups and then to the sub-epics and into the epics. And on the right-hand side tracking, you want to look at a horizontal view. If you want a roadmap and group milestone and iteration are defined at the epic and at the group level. And then a roadmap is a horizontal view of sub-epic and subgroup. And then you have a project milestone that is a horizontal view of issues at the project level. So this is the section where we should have, went ahead and completed the lab, but we already did that. So the next step is, well, now we have, organized ourselves, defined our work, assigned certain issues to the application developers. Now the application developers have accomplished, implemented certain meaningful functionality that we would want to package that app, commit that source code to a source code repository, have a certain steps executed in order to package that application to be deployed to a target environment. Now, how do we accomplish that? That would require some amount of, a sequence of steps. Now we understand the task at hand is to define those sequence of steps, which we normally call as some golden paths of adoption. Now, the first one will be a CI/CD component that will make it easier for teams to adopt GitLab CI/CD and take some of the load of their development teams. Now, we're going to look at what exactly is a CI/CD component. Now, GitLab has released that CI/CD components, making it easier than ever to build pipelines at an enterprise scale. You want to look at if you have used Lego blocks, to unleash your creativity and build your projects, various pet projects. You might want to consider CI/CD component as such a Lego block. It gives you the flexibility of using it in multiple ways, in multiple pipelines. Each component is released as a true app. So the component is considered it as a small app that you're going to implement it, test it, version it, and release it. And then it can be directly passed variables through input parameters. So if we are going to implement the component in a certain manner, that it gives you flexibility to provide certain input parameters. An example of that use case would be you would want to pass a certain input parameter based upon the environment that you're going to deploy. In your path to production, you might have a development environment, a test environment, a pre-production environment, and a production environment. So this gives you flexibility to pass appropriate parameters specific to that environment. Large discoverability, not just from GitLab, but many partners as well through the component catalog. So the component catalog is a repository of all the components. We are going to look at the various sources of these components as to who manages them or so. GitLab, the company, partners, and teams can contribute to these components at a public or private level. So if there are certain, like a CI/CD catalog, if it's going to be the source code is going to be publicly available, like the ones that are published on GitLab, you can contribute since GitLab as a platform is an open core solution. So anybody can contribute to the open core. It helps us kind of advance the capabilities of these components to others as well. There might be certain components that your internal teams build that you would want to keep it private and make it only available for your organization. So depending upon that, you can scope it uh, and then publish it to the catalog. Existing component examples I talked it. If you look at the tags here, GitLab maintained are the ones that are, our application teams implement them and make it available. Of course, since it's open core, you can contribute as well. And you see at the bottom, there's a Cloud Run component that is being provided by our partner Google. Um, and then there are these components which don't have a tag, which indicate that these are implemented internally within your organization, specifically explicitly to be used internally. And just like any other good programming language and scripting language, GitLab platform allows you to certain conditional controls in place, so you can define as to when do these steps within the pipeline needs to be executed, job at when they need to be executed. If there are any failures available, there might be certain jobs within your pipeline that are allowed. The failure is acceptable in a lower level environment. So there's some flexibility in terms of how do you accomplish those things. So we are ready to go back and execute the steps in the lab for the second issue. I'm going to go on the left-hand side, we are going to go to the issues section. On the right-hand side, we're going to go to the higher level group and to the project. Pipeline orchestration, we are going to expand this. Now we're going to review, now that we have work plan, and let's start by creating our first golden path to simplify our company's CI/CD adoption. Now to start, use the left-hand navigation menu to click through the build pipeline editor. And you can see so in this simple pipeline, you can see we have 3 stages: build, test, and release phases. And then within each of these stages, so this is the stage, and then we have certain jobs. So the build job is tied to the build stage. And then there's set of instructions needs to be executed before script. And then you have a test job that is part of the test stage. So a simple pipeline, we have 3 stages, a couple of one job in each stage, and some semantic versioning. And then, the pipeline editor allows, some features to, visualize it graphically as to, we have these 3 stages, visualize what jobs are in each of those stages. After we have authored, then it allows you to validate our YAML script. As you know, the YAML is very strict in terms of indentation. As to this kind of tools helps you to validate that. And this is a full configuration. There are certain aspects within this configuration that get automatically injected by the pipeline. So it gives you a complete view of the pipeline that is going to be executed by the platform. So we can move on to the second step within this issue. So we have a recent company mandate that all projects need to use linting to meet company standards. As a member of the platform engineering team, we see this as a great opportunity to release a build, test, and linting component for public use. Now let's first test how we would integrate linting on a base pipeline, solving any issue so that our core workers don't have to have the same experience. Now we want this to run in the test stage, so let's add the code below to the end of your existing CI/CD pipeline. So I copied the code snippet on the left-hand side, and we are going to add just below the test job. So the lint, we have a new lint job that's part of the test stage. So you're gonna add an appropriate commit message. Lint job. Now, as soon as we committed, it triggered a pipeline execution. You can see on the top the pipeline with the ID here. So if you go ahead and click on that, that's one way to navigate to an executing pipeline. You can always also use the tab on your left-hand side, build pipelines here to go to this particular section. It displays all the pipelines, and of course, the latest one is going to be on the top. You can see that we have 3 stages: build, test, and release, and respective jobs within each stage. This is a jobs view. We have 4 jobs executing. Now, while we wait on this pipeline execution to complete, it's a good time to run a poll and see. We have some interesting polls. So I'm going to ask one of my team members to pull up a poll while we wait on executing it. So where are you on your DevOps journey? I'm sure there are some organizations are more mature than others. So we just wanted to understand as to where your organization is with relation to adoption of a DevOps journey. So from the results, it seems like 75% are using the CI component. Only 25% are using the continuous delivery aspect of it. So at least it's a good sign that 100% of your organizations are using some portion of the CI/CD on the DevOps journey. Unfortunately, you don't seem to have a mechanism to measure metrics to understand the benefits of using a DevOps journey. So in the later part of this workshop, we're gonna see how our platform has built-in capabilities to measure those. So while we have the build job executed, a test job executed, and then the lane job failed, we can go ahead and click it and see what are the steps that are executed as part of it. So as you can see, the lint job did execute. It downloaded some of the packages in order to execute it. But then so our linting is of our it doesn't pass, but that is intentional. I want to make sure that it doesn't pass, so that intentional how the failure looks like. And then if you go to this is another portion of the GitLab's AI tooling, where you have this troubleshooting feature as to understand why your pipeline failed, readily available at the fingertips of the application developers and DevOps folks. So if you click on that, so it explains you what's the root cause of the failure. It suggests you few example fixes. So you have this readily available. It kinds of accelerates, to achieve some of the outcomes that we discussed earlier. Removing the friction in your path to production, and reducing that time to market of new product features. Now we're going to go back to the higher level workshop here, and then we're going to switch to see how we can make this particular snippet that we implemented as a reusable component that can be injected into multiple pipelines. Um, we know that other teams at the company are struggling to correctly test and build their applications through the use of many different tools. So we want to pave the way for creating components that can easily use to build their software. Now, for example, you could create a build test lint component and publish it to the component catalog for others to use. This will introduce automation, add repeatable steps and standards to your processes, and saves time for your developers and DevOps engineers. So we looked at this step as the execution of a running pipeline. We looked at some of the errors and how we can use the troubleshooting feature. So we can go ahead to the task step number 2 here. So we're going to go at this level, the test group at the group level. So if you're in this view, you should see the Tanuki Racing Platform Engineering Workshop project within that group. We are going to create our component between a different subgroup. And then we are going to name that subgroup as a CI/CD component. So consider this as a grouping of all the components that you would want to implement within your organization, a centralized location. You can go ahead and create a new project. We're going to start with a blank project there. We are going to name that as a golden path component. We are going to leave the defaults. And you have a brand project that is created in this manner. It should only contain the README section with some default content that has been included as part of it. In order to implement our component, we're going to go ahead and navigate to the Web IDE. So in the Web IDE, on the left-hand side, you see a tab here on left-hand side. You're going to go ahead and create a new folder. We're going to name that new folder as templates. So whenever you're implementing a new component, it needs to have a certain directory structure. So we're going to talk a little bit more about that once we have completed implementation of the component. So for now, we have created the templates, and we are going to go ahead and create a file within that template. So I'm going to copy this section, golden path component.yaml, create a new file. And I'm going to prepend that file with my GitLab ID. So whatever your GitLab ID is, and then I'm going to paste it. So it should look something like this: GitLab ID hyphen golden hyphen path hyphen component dot YAML. And so you have that file created. I'm just going to copy the code snippet from the left and screen to paste it here. So if you look at the um, this particular pipeline, it contains two sections. One section is the input parameters that we have flexibility of passing it on. Like the project name, we can, the default one is app, and then we are going to look at when we are going to use our component within a CI/CD pipeline. We're going to override this and define a name of ours, which is going to be the GitLab ID. But at this point of time, and then you have different stages here. There's a build stage, there's a test stage, and then these are jobs that are tied to the respective stages. On the left-hand side, we can go to this source code screen and add something meaningful. Component implementation, and commit and push it. We're not going to create a new branch. We're going to commit to the default main branch that we have. Now that it is committed, we're going to go to the project. So it should look like this: your group, your CI/CD component subgroup, and then the golden path component. Now we defined within the template section as to what's the implementation is this component. So we need to make this component, we just have to treat this as an application, and then build a pipeline in order to release it or publish it and make it available to be consumed by your wider organization. So the first step is going to be in the settings section. We're going to go to the general. We have the project name defined. We are going to give a simple description to this. You can copy it from your left-hand screen, save it into the project description, something simple. And then you can go ahead and save the changes. And then we're going to expand this visibility, project features, and permissions section. And then if you want to scroll down all the way to the Save Changes button, and just above the Save Changes button, you see CI/CD catalog project. So in order to convert our ordinary project that we have till this point of time and make it available in a CI/CD catalog project, you have to toggle this and save the changes. And if you go back to your golden path component on the top, and then you see your project name, next to your project name, you should see that it is now marked as a CI/CD catalog project. So this is a special kind of a project now that we have configured to make it available in the catalog. So we need to release it now and make it available. So we're going to go ahead and on the left-hand side, just like any other application, we are going to go to a pipeline editor. And then we're going to configure a pipeline. And then we're going to copy and paste the left-hand section. Control A, delete it, what you have, and paste it here. So this pipeline has only one stage, which is the release stage. And then we have a variable defined CI commit tag 1.0. And then we have release defined in the create release job. That's part of the release stage. You have this section where it's going to be released with a tag of the CI commit that we defined here. We can go ahead and commit these changes. And just like an application pipeline, it's going to trigger execution of a pipeline. So this job succeeded. If we go back to this pipelines, let's have a look as to why this job failed. Maybe I'll try the troubleshooting section. Okay, so the suggestion is that the particular tag of 1.0.0 already exists. So I'm going to increment it to a patched version, change from 1.0.0 to 1.0.1 and release a new version.
And
I'm
this
going to
is
go back to,
actually a good note. If you also do up the release version, the instructions will still reference 1.0.0. So further instructions where we're saying, pull in 1.0.0, just make sure you also do 1.0.1 instead.
absolutely. Thank you for that. And go back to my GitLab YAML file. I'm just going to edit it as a single file and change it to 1.0.1. Commit the changes. Sorry, I'm just going to say update the release version. I'm going to go back and make sure that the new pipeline has been triggered and it is successful. Okay, it is successful. And then we're going to go into the left-hand side where you see this deploy. We're going to make sure that we have a release. So we see that we had an earlier release of 1.0.0 and then the latest release of 1.0.1 in the CI/CD catalog. Now, before we press ahead, we talked a little bit about a certain directory structure. So I want to go into this web IDE mode one more time. So the directory structure of a component is kind of a very strict in the sense that you need to have a templates folder. Within the templates folder, you will define the meat of what the component pipeline would look like. And then at the higher level directory structure, you will define the GitLab CI YAML file, just the release stage and the release job, which gets executed just like any other your application specific project, and then releases it and makes it available. Now it's time to bring it all together. At the higher level group, we're going to go to the higher level group. Then it should look like this. You should have your Tanuki Racing Platform Engineering Workshop application specific project. Go inside and then let's view our the GitLab. I would rather go on the left hand side and go to the pipeline editor. Then view. So this is a very simplistic way of our implementation where we incorporated all the steps and jobs within the application specific project. So if another application team that's implementing another um, business functionality specific project, and they would want to use the same pipeline, they kind of have to replicate this same functionality, same pipeline functionality over there as well. So it's a lot of duplication of effort. So in order to eliminate that, we just centralized this into a component and published it to the CI/CD catalog. So as you see here on the top, we can navigate it to the CI/CD catalog, and then we can look into, this is kind of a repository of all the components that are available. We're going to navigate into this tab, the Your Groups tab. Now I'm going to search for my, I believe it's the golden path component. And then you see I have two components that are, one is versioned 1.0.0 and 1.0.1. I'm going to click on this. And then it's going to show us what's the simplistic way of including that component within our application pipeline. You see a component, it shows you an include statement, which is referencing this component, so you can copy that. But before we press ahead, I just want to show you the input section here. I see there are two inputs to, it's the same parameters that we included in the component implementation, the project name, and then the Ruby image. Is it mandatory that we pass on these two variables when we invoke this component from our application specific project? No. What type of parameters are these? Description, what the default values are. So I'm going to go back to this particular tab where I have the main, and then I'm going to copy this part, which is in 6. Here is the finished CI/CD YAML. I'm going to copy that section and then replace it here. At this point of time, I want to make 2 edits here. If we want to go into the catalog, copy this section, which is very specific to, here it shows my particular location. Yours might be different. So if you copy it here, that includes, and then so I'm going to remove. So yours should reflect in this fashion. Obviously, you would have a different group ID, and then you would have a different GitLab ID, but you copy this snippet from here. You don't have to make any modifications there. And then the project name, if you would want it to modify it to your group ID, GitLab ID, sorry. So it shows you that we have injected this component within our pipeline. As you can see now, our pipeline is very simplistic. It has an image, it has a certain Docker image services, and then certain variables. We defined the build, test, and release stage, but we haven't defined any jobs. The jobs are going to be injected into this pipeline through what we already implemented in the component. And then in the end, you should see that the version is 1.0.1. So if I go ahead and commit this, it should result in triggering of a pipeline. Navigate it to the pipeline. You see the jobs that we defined in the component are automatically injected into the pipeline. So on the left-hand side, I forgot to assign it to myself. I can go ahead and assign it to myself, what I should have done before working on this issue. We're going to let this pipeline execute, and we're good to close this issue. I'm going to go to the issues section. So we have two more issues that we need to work on as part of this workshop. But I think at this point of time, we are good to take a break. So I would ask that we take 15 minutes break, and let's come back maybe around 12:40 or 40 minutes past the hour.
With timing, I think we should aim for 1/2 past, so at the 30-minute mark. That's all right.
Okay, it's okay. So it's at the 30-minute mark, please. All right. I hope everyone's back. If the participants, if you would like to give me a thumbs up or done back in the chat message, that would be great before I get started. All right. So until this point of time, we talked about the benefits of platform engineering approach. In the second section, we talked about how do we um, organize ourselves not only as teams, lines of business units, how do we define our work, um, in order to manage it effectively. We define epics at the highest level, which is a bucket of sub epics, which is a bucket of project specific issues or so, and then over a timeline, how do we measure the progress of our delivery from horizontally standpoint? We implemented simplistic pipeline. Uh, we we leverage the feature of componentization. How do we centralize reusable pieces of our pipelines and make it available, publish and make it available to the wider stakeholders, your application developers and DevOps engineers to integrate it in their pipelines to accelerate that path to production. Now we were at a point that we would want to, ensure that what we are delivering to production environment is secure. And how do we make sure that our source code that's getting deployed is secure? Next, we want to make it easier than ever for developers to keep their applications secure. Now, we will define pipeline execution policies uh, that us and then the security team can maintain so that our developers can focus on writing code. The benefits of GitLab as a single platform for complete entire DevSecOps journey is that you have as a source code management system, you have the source code repository, and then as a CI/CD platform that delivers that source code, packages it, and deploys it to the end deployable environments. Um, so you have it gives you flexibility in terms of injecting these security paradigms. So you have a source code management system, you can execute static SAST-based scanning capabilities. And then along the way, lots of other scanners can be injected in your path to production. When you deploy to the environments, you have a dynamic scanning testing capabilities incorporated. Thereby, you kind of a shift left paradigm where you identify vulnerable software very early on in your development process before you introduce the source code into a release branch and into a main branch that is primarily main branch is a reflection of the code base that gets deployed into your production environment. Policies for compliance to ensure you can define certain policies where use it as a guardrails in terms of if there are specific approvals needed by individuals from your security team before certain vulnerabilities are accepted, or and at that point of time you have guardrails gate in place where you can create issues and assign it to the application developers to resolve those vulnerabilities and not allow them to be introduced into your release branch. And it gives visibility across your entire software development life cycle, so end to end. System-wide governance, the governance we're talking about is, what's your security posture of a wider application portfolio for your entire organization? Kind of gives you that visibility as well. This slide shows you as to the cost of remediating security vulnerabilities at each stage when they get identified. So as you can see in the graph here, the cost kind of exponentially increases when you navigate from your lower level environments to your higher level environments, the identification and resolution of those exponentially increase. So it's better to identify them very early on and remediate them. And not only from a, you know, reducing costs, but also in terms of, uh, reducing risk of being, vulnerable software being taken advantage by bad actors. Now, this is total the impact analysis that we did with an organization with 5,000 employees with an annual revenue of approximately $5 billion and implementing GitLab over a period of 3 years. Software improving software development team productivity. Now you have a single platform with various stakeholders, and then we simplify that path to production. Removing that friction that enables everybody to be more productive. Improved productivity of new hires. We are leveraging certain capabilities of the um, platform. One of them we kind of implemented today, which is a componentization, where you make reusable components available so the new hires don't have to reinvent the wheel, and then end of use what's available, discover and use what's available, thereby improving their productivity. Accelerated time to market. We talked about the platform engineering goal of shrinking the time between idea to delivery of the product or production environment. Achieving that product market fit sooner than later. Improvements around security and compliance related activities. We are going to talk through that in the next few slides, and in the next workshop issue, we're going to see how we can seamlessly integrate security and compliance in the path to production, and benefits from tool chain consolidation. Rather than stitching together various tools provided by different vendors. We're going to have a consolidated tool chain with all the capabilities within the platform, thereby achieving those savings. Um, DevSecOps platform enables developers efficiency because you have application developers focused on implementing business functionality. You have security team, which is more focused on enforcing those guardrails. Everybody's in their own swim lanes, but the platform kind of with its the tool set that's available for those to these stakeholders, kind of everything comes together and helps developers be more productive. End-to-end governance, this gives visibility into the security posture of your application portfolio over a timeline. So you can see trends as to whether the posture is getting better, declining, so you can take appropriate measures. Efficiency, we're going to talk and show some of the capabilities of the metrics capabilities within the platform. There are some battery package dashboards that are readily available. And then it allows you to build your own value stream dashboards based on metrics that matter to you. And the only way we are able to achieve this is having a platform that provides plan features, that provides CI/CD features, that provides um, security features. Thereby, we have a unified data set, and it gives us the ability to measure those metrics that are important for you. We're going to go into the workshop with our third issue. So as we can see, this is the pipeline that we started with, incorporating the component as executed. As expected, the lint job failed for the reasons we have discussed. It's our source code is not completely lint compliant. So we're going to go to the higher level project here. And on the left-hand side, I'm going to select the integrated security issue number 3. Before I forget, I'm going to go ahead and assign it to myself. The pipeline compliance. To further ensure compliance within your application, we are going to enforce pipeline execution policies. so that the security team can maintain our scanners while the developers focus on their work. The pipeline execution policy, once our new component pipeline has run on main, we can check its status by clicking on build pipelines. We already did it. It is not uncommon that when it comes to deadlines, our developers may tweak the pipeline to skip a few security checks to get features out of time. To prevent this and further secure our CI/CD environments, we are going to set up a pipeline execution policy. To start with, we will use the breadcrumbs on the top of the page to click in your group. So we're going to go to one level up in the hierarchy, where you see we are in the group section, and we can see our workshop source code project, and then the CI/CD groups that we implemented earlier. We're going to go ahead and create a new project. We're going to start with a blank project, and we are going to name it as scanner pipeline. And create the project. So just like any other project is created with some README file and some standard README information in there. So we're going to go to the pipeline editor. So we're going to go ahead and configure a pipeline. We're going to copy the snippet from left-hand side. Sorry. And paste it here. We're going to review this pipeline. It contains a standard section of the image, services, and some variables that are defined. And then there are certain set of stages that are defined within this pipeline. The most important section that I want you to focus on is this in the include section, where we have certain scanners injected into this pipeline. One is, some of them are injected through a template, and the other one is injected, one of them, the secret detection scanner is injected through a component. It's included, some SAS scanner. We have infrastructure as code scanner, you have dependency scanning, container scanning, and the secret detection scanning. We're gonna go ahead and commit the changes. So we're gonna ignore this pipeline execution. We're gonna go ahead at one level up in the scanner. One level up actually at the group level. So if you are, a security team member, you have a centralized place. We took it as a very simplistic approach of defining our scanner pipeline project within this group itself. But just as we approached the CI/CD component, we created a subgroup and then defined our component within a subgroup. We can also would have done that, created a subgroup and defined our scanner pipeline. So, you yeah, you have different buckets of application teams working on different groups and security teams focused on building the scanner pipelines and managing it as a separate project, just like any other application. If you need to incorporate a new scanner within that scanner pipeline, it's the security team that has security team is the only one that has access to that particular group and then the project. So we are ensuring that application teams and security teams, operate in their own swim lanes. So application teams cannot really override any of the security paradigms that your internal security team would want to enforce. So now we have that in place. How do we enforcing this pipeline compliance? We're going to go into this workshop. And then on your left-hand side, you see this security tab, and then go to this policies section. We're going to define a new policy. We're going to use the pipeline execution policy. Pipeline execution policy to enforce a custom CI/CD configuration to run in the project pipelines. Example is run a GitLab security templates across my projects. So we defined a security project and we are going to use that to incorporate that in our application specific project so that those security scanners are automatically injected when the application specific pipeline runs. So before I press ahead and create this policy, I just wanted to highlight that there are other approval policies available as well in order to enforce merge request approval policy as a gatekeeper before any source code is merged from a feature branch to a release branch. And the other two for those specific as to execution policy as to what kind of scanners, particular branches or certain times, vulnerability management. If it auto with the platform this policy automatically detects that a vulnerability that was detected previously is no longer found as it's marked as resolved. So there are certain types of outcomes that we want to achieve with these specific policies. Let's go ahead and select the pipeline execution policy. I'm just going to give it an appropriate name, my GitLab ID, pipeline execution policy. Description, maybe a simple pipeline execution policy. Within the actions section, so policy scope here, apply this project to apply this policy to the current project, the one that we are actively working on. Inject it, and then we are going to select the projects that we want to be injected into this particular application project. We define the scanner pipeline. I just want to make sure that I have two scanner pipelines because I created an environment earlier, so I want to make sure I use the right one. So in order for that, I have to look up my group. So I'm just going to use the left hand tab here. So my test group here starts with IUO. So this is the right one for me. I'm going to select the scanner pipeline. Then I'm going to add the pipeline in the secure pipeline location where we define the scanners in this location to be injected. I want it to be applied on the inject as selected and choose your scanner project. We just need to add the CI file. I'm going to leave it at the default branch. And then update it via the merge request. So it will result in creation of a merge request. I'm going to go ahead and merge it. Ensure that you merge it. It's only after you merge it that the policy goes into effect. We're going to use the breadcrumbs to navigate it back to our group level. Now, once you navigate it to the group level, you see a new project is automatically created by the platform. It is generated by the security policies project for this project. Now, if you go inside as to review what's inside this special security policy project that is being created by the platform, You see a standard, you see a README section. If you go into this particular folder, GitLab security policies, there's one file policy.yaml. You can see that whatever configuration that we made through the UI when we defined the pipeline execution policy and then associated with the project, it's kind of generated this, so it's kind of persisting policy as code. So at any point of time, you would be able to visualize it um, in this format. Let's go back to the group level and let's go into our workshop project. Let's go into the build pipeline section. Give me a second. So at this point of time, so we have associated that security policy with this particular project. So we want to manually trigger this pipeline. New pipeline and trigger the manually trigger the new pipeline. As you can see, there are certain scanners that are automatically injected into the pipeline, and we accomplished it by associating the say, scanner pipeline project with our workshop project. While we wait on execution of this pipeline, it would be a good point to run another poll. If one of my colleagues can help bring up the poll. That's good. We have a fun poll now. Now, if you could be one animal, which one would you choose? If you want to choose a national bird or one of your pets, it would be fun to have dolphin as a pet. We just got one respondent, and they would prefer the national bird. Cool. So you can look a little bit on stages. As you can see, we have two stages, build and test. All our scanners are injected into the test phase, just like we defined in the scanner pipeline project. I was just gonna give a few more seconds to let this finish. Okay, now that all our scanners have completed, we would want to see the output of the scanners. So we go to on the left hand side in the secure tab. We want to go to the vulnerability report, and see this should get populated. Just gonna wait until it gets. So as you see, it's getting populated now. You see the 5 critical, and then if you keep on refreshing it, you see the count getting increased. Um, so it's getting increased, but the important point while it's getting populated, I want to highlight is, you can filter this further based upon the severity level if you want to look at all the critical ones. And, just there are multiple criteria that you can use to further filter. I'm going to use scanner. Uh, and then select maybe the SEMGrep SAS scanner. And then you see certain things highlighted, and then want to click on one of these. Right at the bottom, you can take certain actions. You can go ahead and create an issue and assign to an application developer to work on, add to an existing issue. On the top, you see the edit vulnerability. You can change the status if you believe that this needs to be at a certain, a certain severity level and certain status than what the automated scanning tool determines it to be. You can change that as well. And as you see on the top, you can see the explain or resolve with AI button there. So this is another place where GitLab's artificial intelligence tool is injected and readily available, and make it available at the fingertips of the stakeholders so that certain actions can be taken. So we want to understand this vulnerability a little bit better. I'm going to go ahead and explain with AI. I'm going to scroll onto the top. It starts with a vulnerability explanation. What's the impact of this vulnerability and attack scenario? How bad actors can take advantage of this vulnerability? And what are the remediation steps that we can take in order to fix this vulnerability? And the best practices to follow in your implementation going forward. But not only just understanding it, but also you can trigger a resolution as well. Now, what this resolution does is it creates a merge request. It modifies the existing files, it fixes the error, and then makes it available for a human to review. Now, we are not going to trigger that as part of this workshop, but if you're interested in learning more about the artificial intelligence tooling that is available in the platform and across the platform, I would strongly suggest you to sign up for the Duo-based dedicated workshop from the same place you signed up for this workshop. And go to the top level section. Now we have identified, let's go back to that code again. Now we have identified significant amount of vulnerabilities, and we intentionally using a source code that contains the vulnerability. So this dashboard is populated. So having 1,000+ vulnerabilities on a flagship application for your company is very worrisome. So our team starts to work through the issues. We also want to ensure that future vulnerabilities cannot be committed. So how do we enforce that? Preventive security policies. So we're going to go back to the higher level. We talked a little bit about the other policies in addition to the execution policy that we implemented. We're going to go to the policies section, as you can see here. The one we defined it and it's enabled. And go to the new policy. And we're going to look at the merge request approval policy. I'm going to name it appropriately with my GitLab ID. Merge request approval policy. It's enabled. The scope of this policy is to this current project. Select. And then I'm going to use this policy for a specific type. Just a second. Select security scan. And in the all scanners, I want to clear them, and I only wanted to use the secret detection scanner for this particular policy. And I'm going to apply this only on the default branch. And in the action section, I would want to define certain users. I'm going to click, and I want all of you to select LF Stucker as well. So what this does is actions is we are enforcing that one approval is required, and that approval is from this particular individual user. We would have also selected groups if all your security team members are part of a particular group or they're associated with a particular role. We could have selected those as well. And in the override project approval settings, we want to uncheck prevent pushing and force pushing. Just a second. Force pushing. I'm going to leave all the other ones the default. Maybe add a simple description. I'm going to go ahead and configure with the merge request. We're going to go ahead and merge this to make sure this policy is applied. Now that the policy is applied, I want to use the breadcrumbs to navigate to the at this level, the group level. And what I want to show you is in the automatically generated security policy project, within the security policies and then the policy YAML. And now there's another policy that has been applied. Earlier, we only had the pipeline execution. Now you have the merge request approval policy as well. I want to go back to the higher level group. Now we are going to introduce a secret into our workshop project. So the merge request policy, since we applied that secret detection, it should detect that there is a secret and then block us from merging. And go to the web IDE. And within the CF sample scripts folder, EKS YAML. On the left-hand side, within the second task, I'm going to copy this. In here, you can see AWS key ID. It's got a pattern. We're going to copy that and replace that in line 6. So we are intentionally introducing a pattern that looks like an AWS key ID. On the left-hand side, go to the source code. And then we are going to commit it to a new branch and commit. We're just going to press enter. You're going to click on the create merge request. And we are going to scroll down all the way to the bottom and uncheck this delete source branch when merge request is accepted. Create the merge request. So if you navigate to the pipeline, you can see that our secret detection is injected as part of the pipeline execution. And then if you go back to the merge request, so it's checking where all the policies to make sure that all policy rules must be satisfied. So it's going to take a little bit of time for this to execute. So we're going to come back and check the behavior of this particular evaluation after these policies have been applied. The expected behavior is that the merge request should be blocked until and unless the person we assign approves this merge request. So at this point of time, we can go ahead and then the left-hand side close the issue. So if we navigate here, I should have one last issue left. Go back to our slides. So now that we have gone through the steps of, understand the benefits of a platform-based approach, we talked about how do we organize ourselves. We implemented simple pipeline. We componentized a certain piece of the pipeline so it can be widely adopted, accelerating, CI/CD adoption across your organization. We talked about how do we seamlessly integrate security into the pipelines for wider adoption and ensuring that secure software gets delivered to your production environment. Now it's time for us to measure all the things that we have done so far um, to see, are we gaining benefits out of this approach? Now, we don't just want our developers to say that we offer great solutions, but we want to back it with data as well. Now, our next task is to see how we can use the built-in GitLab analytics tools to back up our successful platform engineering claims. Post-plan metrics. Now that the plan is set, what's next? GitLab enables product managers through multiple observability tools to make sure that you're informed that your team's plans are being executed on time and efficiently. Analytics exists for every part of the SDLC, but this is done primarily through our value stream analytics dashboards and the DORA metrics dashboards. DORA stands for DevOps Research and Assessment. I'm sure most of you are aware, and is made up of measuring things that are important in terms of deployment frequency and how frequently do we deploy. The higher the frequency, the tighter feedback loop do you have. Lead time for changes. Um, the lead time for changes, the minimal amount that you have, uh, your time to product is kind of very simplistic, or you're making from an idea to delivery of new product features is very timely. Change failure rate, your execution of your delivery pipelines, and all of that sort, and time to restore service in case of failures. What does it take in order to restore service? Now, GitLab measures these projects at both group and project level. Um, so if you have executives that are interested in having a holistic view at the group level of multiple projects, that can be accomplished. Individual teams that are working specifically on individual projects, they're more interested in the project level view. The value stream dashboard is meant to be a tool that you can identify, that you can use to identify trends and patterns over a period of time, and strive for transformation. This kinds of makes it visible in what areas you're doing well, what areas you would need to focus on to further improve. Workshop instructions. So as we discussed, the metrics are key to measuring the impact of the platform engineering and where you need to shift your focus to make informed results. To start, we will look at a few of key metrics. Use the left-hand navigation menu to click through Analyze Analytics dashboards. Let's go back to the group level. And go through value dashboards. So you can see at the group level, you can see it's grouped into three sections. Lifecycle metrics at the group level, you have your DORA metrics and you have your security metrics. The first one is more focused on lead time to delivery, cycle time, number of issues created, issues closed, deploys. This dashboard is not populated with a lot of information, primarily because these test groups as part of these workshops are dynamically provisioned individually for each participant. So this only reflects the activity of what I have done. Only single contributor, done only 3 commits or so. DORA metrics, once it's fully populated, it kind of reflects your deployment frequency, lead time to changes, time to restore failure, service in case of failures. Security metrics, it's a holistic view of all the projects within the group as to critical vulnerabilities over time and high vulnerabilities over time. And then various others, like the value stream analytics or CI/CD analytics, number of releases, projects with releases, contribution, met analytics, um, contributions per group, number of issues created, things of that sort. DevOps adoption, you can see it's bucketed into just the developer piece in terms of approvals, code owners, issues, merge requests, or operations as well, deploys, pipelines, runners, security related features adopted. So it gives you a holistic view of adoption of various capabilities of the platform within the organization. This is the overall adoption of the AI capabilities that are available across the platform. Productivity analytics. And then the third piece of it, if we're going to go to analyze value stream analytics, it allows you to create a new value stream in addition to the the default dashboards that are readily available. So if you can, it's custom VSA, and then various stages you can define as to, there are certain that are default populated, but you can also define your own stages and define things that matter to you. And select the event that really matter. I'm just going to scroll down all the way to the bottom. Merge request reviewer first assigned to code delivered, maybe. First deployed to production. Stage, and then you can create a value stream. And as and when you work on deliver your work, it shows you the minimal amount of work that we did today. So you can build your custom value stream analytics dashboards as well. That pretty much concludes this issue as well. And I'm going to assign it to myself, something that I should have done before starting, and then go ahead and close the issue. Just going to go through the summary slide. So we discussed various aspects of platform engineering. We discussed the planning phase, pipeline orchestration, security integration, and measuring the benefits that we achieved by implementing this platform engineering approach. Now, after you've completed, as mentioned earlier, this lab is going to be available for you for the next 48 hours. So if you are behind on any of the lab, so you can execute it. And then once you're done, you can transfer the project. Now, the transferring the project should be the last step after you've completed everything. That concludes it for today. And thank you very much for taking time to join with us. If you have any questions, I'm going to hang around for a few minutes. You can post your questions in the Q&A section.
Awesome. Thank you, everyone. Thank you, Ajit and team, for helping out. A small but mighty group today. Like Ajit said, we're here to answer some questions right now, live Q&A. We'll hang back. And if not, I'm going to go ahead and post the next workshop. So we do these workshops every month, different topic every month. And next month, May 15th, we're doing the platform management one. So if you have any questions, go ahead and use the Q&A. We can answer those live. Again, May 15th is going to be our next workshop date.
For live QA, Lori, did you want to answer one of the questions you've been working on?
Yes, I was typing that in. Thank you for that. So this is a question that Andrew Chow had asked, primarily around the issue board. In that, when an issue board is created and you add to that issue board a list, that list then you scope it to a label, and that label that you scope it to is to a scoped label. Now, what happens there is that, and you have other lists that you've added with the scope labels to that board as well. So what happens when you drag an issue from the backlog list on that board over to another list that has that scoped label or has a scoped label, that issue will automatically be updated with that scope label added to it. Now, you may not see that in the issue card itself on the board. And when we say the card, those are those little items that represent the issue on the board itself. You won't see that label in that card because it's actually part of the column in which that scope label is or that issue that had been added to for that scope label list, if you will. But if you click on that card in that list that you move to the scope label list, you will be able to, a drawer will open on the right side to give you details of that issue where you will see that scope label has been added. Now, if you take that same issue, you drag it over to the next list, and where it has another scope label, then automatically the previous scope label will be removed and the new scope label will be added. Now, if you click on that card in where you've dragged it to the new list, you might see that that label has not been updated. And so what we found is that if you refresh your browser, that will update it, and get you back to where it needs to be. Now, we have seen this kind of a weird behavior, and so we're going to take this back internally to make sure that this is taken that we address it with the product team. But hopefully that addresses your question and makes sense. And thank you for showing that, Ajit, or whoever's showing that.
It's me.
Okay,
I'm
perfect.
showing it
Thanks.
on the
Thanks,
screen,
Ken.
but hopefully that helps illustrate a little bit of what we're seeing in terms of the usability. So Lori's totally correct. Yeah, I think it's maybe just an optimization and something we should definitely look into.
But clicking on that card like you did, Ken, you'll see that it's now got the correct scoped label on it. And as he showed, if he drags it over to the next column, you'll see that previous label disappears from that card view. But when he clicks that, it's still showing that. But now if he was to refresh that browser and click there, you'll see that it's now been updated. So it's just something that's odd in the back end there that it's not, refreshing in the screen for you. So, but guaranteed that it does work and it is doing what it's supposed to do. It's just not, reflecting it back in the UI correctly.
Yeah, so good catch. Yeah, and Andrew, if you feel like being a good citizen and adding an issue on GitLab.com, we'd love that. In the background, Lori and I will of course go and see if we can find an existing issue on this, and if not, thanks so much for finding it. Obviously,
Yeah.
something we want to get fixed and make more rock solid. So appreciate that.
Sweet. Glad that it worked out. Like we said, if there are any other questions, feel free to throw them in the QA section or just in the chat. We'll hang out for a few minutes and just answer what comes in.
And if there are no more questions, once again, you will get the recording, you will get the slides, you will have 48 hours to come back and complete the workshop. And then we do these every month, so hopefully we will see you at the next one. Alrighty, thank you everyone. We'll see you March 15th, or sorry, May 15th, I should say. Thank you.